3 is underway. Enjoy.
My guest today is Dr. Daniel Owens, lecturer in cellular and molecular sport and exercise science at Liverpool John Moores University, a sport nutrition consultant to the Warrington Wolves Professional Rugby League Club, and former performance nutritionist for England Rugby Football Union. Dan, appreciate you taking the time today.
Thanks, Mark. Yeah, I really appreciate being invited on as well.
Terrific. Well, can you start here maybe with giving listeners a quick whirlwind tour of how you became first interested in nutrition to your current role at Liverpool John Moores?
Yeah, of course. Yeah. So, I guess my interest in sports nutrition and sports science probably started in high school. I was really interested in biology at that time, particularly human biology, and I was a keen athlete myself. I was playing multiple sports, soccer, rugby, and track running at the time. So, laterally for me, when I left high school, I thought, I want to do something that combined all of this. And luckily in my city, in Liverpool, at Liverpool John Moores University, we have a degree in sports science, and I thought, that's perfect for me. So, as your listeners may know, at John Moores University, we have some really great sports nutrition research practitioners, such as Graham Close, James Morton, previously Don McLaren.
Phenomenal program, yep.
Yeah, these guys had a really big impact on me through their teaching. As soon as I started attending these lectures, I thought I want to be in the position these guys are in, somewhere down the line. I guess I got a first taste for actual practical sports nutrition as part of the degree program. So I was placed with the local boxing council, and that really just led on to more opportunities working with Graham and James until I eventually did a PhD with James and Graham in the area of vitamin D at John Moores. And then I moved away to Paris for a couple of years, worked more on fundamental muscle biology. And then about a year ago, rejoined John Moores University as a lecturer, and I've just since been trying to mix basic science with applied science and nutrition, and that's really led to this research interest of sort of translational physiology research, and that's brought me to where I am today, I guess.
Phenomenal. Well, listen, I'm looking forward to digging into your work on vitamin D and as well exercise-induced muscle damage. So. Let's kick things off here with vitamin D. In the last decade, the research on vitamin D and athletic performance has definitely exploded. Can you maybe give listeners a little historical perspective here and talk about, some of the advancements in technologies that's really influenced some of this understanding of what vitamin D really does in the body?
Yeah, for sure. And you're exactly right that the past decade or so is just seeing this real boom in research that's been taking place in this, focused on vitamin D. Really, we can look back to the early 1920s for, I guess, where this research interest in vitamin D started. Vitamin D was discovered by quite an interesting character, really, in nutritional biochemistry, a guy called Elmer McCollum. And he was really interested in answering the question, how many dietary essentials are there and what are they? So he was just trying to figure out what is it in the diet that we really need, that we cannot synthesize ourselves. Mm-hmm. So he was, one of the first guys looking into essentially what vitamins really are. He was working at the time on experimental rickets, which is a bone disease, results in abnormal bone mineralization. So you've probably seen kids with bowed legs, which is a characteristic phenotype of rickets. And what McCollum was doing with these animals that had experimentally induced rickets, he was looking. He tried over 300 different diets to see, what diet and what it was in specific foods that could prevent this disease. And he pretty much figured out what vitamin D was by feeding cod liver oil that had been heated and aerated, so it destroyed all the vitamin A in that. He figured out that it could no longer cure night blindness, which is a consequence of vitamin A deficiency, but it did cure rickets. So at that point, he named it with the next available letter in the alphabet. So they already had A, B, and C, so he called it vitamin D. And really after that, a generation of kids grew up being supplemented with cod liver oil, and the rickets epidemic that had gone before it was virtually eradicated. So, I mean, since then, and since the identification of vitamin D, that's, I guess, when there was, a steady increase in the interest in vitamin D. Now, I guess if we kind of fast forward a little bit to where we are today, yep. we know so much more about what vitamin D is and what it does in the body. And for me, there are, I guess, the two real interesting facts about vitamin D is that it's not really like a normal vitamin. It's much more similar to a steroid hormone, and it acts in a similar way in the body. And also the predominant way by which we get vitamin D, despite the fact it was identified through a dietary supplement, we actually get it through a photosynthetic reaction in the skin when it's exposed to ultraviolet V radiation or the sunlight. And really through the development of new technologies, we now know exactly how vitamin D gets synthesized in the body, how it gets converted to the active metabolite. So, I mean, it's probably a good time at this point to really give you a background as to what happens in the body when we get vitamin D, because I think it sets up anything else we want to discuss. So regardless of whether we get vitamin D from the diet or whether it's produced in the skin, both forms of it are going to get pulled into the circulation. It's first going to get sent to the liver, where it gets converted to 25-hydroxyvitamin D, which is also just shortened to 25-OHD. And it's this metabolite that we routinely measure as a marker of vitamin D status. So all the current guidelines are based on this metabolite. Currently, anything that's below 30 nanomoles per liter is considered to be deficient, and anything less than 50 is suggested to be inadequate, and anything above 50 is sufficient. So that 25-OHD is actually an inactive metabolite. It then gets transported to the kidneys and other tissues that can express the appropriate machinery to convert it to the active metabolite, which is 1,25-dihydroxyvitamin D. And it's this metabolite that can interact with the vitamin D receptor and actually regulate around 3% of all of our genes. And as I said earlier, the reason that we know all this cool stuff is really due to new technologies. We can look at multiple systems in the body. We can use omics approaches, which allow us, to take an unbiased look at everything that's going on in the body. We can generate, animal models with specific mutations, you name it. So because of the technologies, the interest in the area has boomed, and we've got so much more knowledge now. But for me, the fact that we've learned so much more, I actually think now we realize how very little we know about vitamin D. So it's a
common theme often, isn't it?
Yeah, absolutely. It's a super cool area for me, simply because there's such a wide breadth of avenues which we can explore. So that's about as brief as a background as I can give on.
That's terrific, and definitely with vitamin D receptors on bone and immune cells, cardiovascular system, obviously skeletal muscle, which kicked a lot of this off, and I definitely want to circle back to kind of the testing, because you mentioned the 125 hydroxy. But before we go there, maybe just to lay the lands for listeners of what are some keys that vitamin D may be able to do to impact athletic performance?
Yeah, I mean, there's a lot of research out there on this right now, and I can totally understand when people come to me and say they're pretty confused about what the literature says around vitamin D and athletic performance. For me, there are a few key areas the vitamin D can certainly have an effect on that can affect athletic performance both directly and indirectly. So I guess indirectly is likely to be through suboptimal immune function. As we know, vitamin D is a potent regulator of both the innate and acquired immune system. So work from Professor Mike Gleason's lab in Loughborough and also from some other groups, they've shown that athletes and military personnel with vitamin D deficiency have an increased incidence of upper respiratory tract infections and a longer number of days with those symptoms, which if you think about that from an athletic performance point of view, that means, athletes are losing days of training and potentially days of competition. I think what's interesting about this area is that the amount of circulating 25 OHD seems to be higher than what is considered to be sufficient by the current guidelines in order to optimize immune function. So it appears that the break point for a reduction in infection risk is actually about 90 nanomoles per liter. So if we think back to what the current guidelines are of above 50 nanomoles per liter, we're quite a way off there. So that's really an interesting area, and certainly Mike Gleason is the guy to go and read up on if you're interested in that area. The second key area that really is of particular interest to me and where my research interests lie is in skeletal muscle. So we personally have performed quite a few trials on vitamin D and skeletal muscle, and the one where we've seen the most interesting effects was on a randomized controlled trial in which we took healthy individuals that had low 25 OHD, less than 50 nanomole per liter, and we supplemented them with either vitamin D3 or a placebo for 6 weeks. Now, prior to and following that intervention, we experimentally induced muscle damage by a high volume of eccentric muscle contractions, and then we monitored the recovery of force amongst some other markers of muscle damage. Mm-hmm. And we found a significant improvement in force recovery in the group that were supplemented with vitamin D versus the placebo. So, in keeping with this theme of translational physiology, we wanted to try and identify what was actually going on within the muscle that could potentially explain that benefit. So we took some muscle biopsies from vitamin D deficient individuals. We're able to isolate out muscle precursor cells, and we're able to use them in vitro in Petri dishes in the lab to do some extra experiments on them, and really allows us to look at this in a little bit more detail. So we treated some cells with vitamin D and others without. We kind of mimicked a muscle damage in the dish, and then we looked at how the muscle was able to regenerate itself. So some of the key findings showed us that the cells weren't able to move as quickly to the site of damage, to fuse together, and to essentially regenerate that area that was damaged with the cells that only had that didn't have vitamin D. So basically, vitamin D was able to improve some cellular mechanisms that are responsible for muscle regeneration, which for us is
amazing,
really cool finding, and it's something that we're trying to follow up and understand a lot more about at the moment. The final area for me, I guess, where vitamin D could certainly have an effect is obviously with its effects on bone. So bone is obviously the classical tissue through which vitamin D seems to have an effect, because vitamin D is a potent regulator of calcium absorption and bone mineralization. So if we think back to that early work from Elmer McCollum, that's where we started to understand vitamin D and bone health. Now, bone is obviously a metabolically active tissue. It can remodel itself in response to different stimuli. And research has demonstrated that vitamin D may be implicated in some aspects of this remodeling process. Unfortunately, observational studies they don't really affirm a proportionate susceptibility to bone loss if you've got low vitamin D concentrations, and we think the reason for that is because at least load-bearing exercise is a positive osteogenic stimulus for bone. So what that really means is that if athletes are load-bearing, they're likely going to have an improvement in their bone health, regardless of whether the vitamin D is high or low. To a certain extent, if it's really low, we still see some bone abnormalities. However, one sort of caveat to that is that obviously there are a lot of athletes that aren't weight bearing. So, for example, jockeys, or I guess, the likes of swimmers, guys who are spending a lot of time off their feet and not really doing load bearing exercise. Mm-hmm. We do still see that they have low bone mineral density when their vitamin D is low. So, for example, in jockeys, who are falling off the horse, all the time, we really focus on these guys, try and improve their vitamin D, because it could certainly lead to an increase in fracture risk and bone breaks. So really, to summarize that, the three key areas for me is probably immune function, skeletal muscle repair and remodeling, and potentially bone health are the ones that have got the most evidence at the moment for me.
Yeah, definitely some pretty significant consequences if you're a jockey, as you mentioned, and you get kicked off the horse. I mean, if your status isn't so good, then that's definitely a pretty significant consequence. And Dan, how much do vitamin D levels vary between groups of non-supplemented athletes?
Yeah, generally speaking, if athletes aren't taking supplements or using sunbeds, they have the same risk as everyone else and between each other, because it has very little to do with the diet, but a lot to do with the environment. With that being said, some of the work that came from our lab in sort of 2013, showed quite a large variation actually between cohorts of elite athletes. So we looked at elite rugby players, soccer players, and also jockeys. And we saw pretty big variation between these guys. And our explanation for that really was that there could be a number of explanations. One, it could be dietary differences between the cohorts. It could be sunlight exposure differences, although it's probably not likely because most of the measurements were made in the winter and all of our guys were based in the UK, so very similar sunlight exposure. Could be due to clothing. Again, if you're fully clothed, or if you're only sort of 50%, that's going to have an impact on how much sunlight your skin sees, and also lifestyle as well, predominantly living indoors or training indoors. And I guess really for us that kind of has important ramifications for supplementation, because it tells us that we can't really just assume that all athletes in the winter months have the same requirements for vitamin D. So we've tried to kind of help out with that by producing a decision flowchart in one of our recent reviews in the Journal of Sports Medicine. And, that kind of helps practitioners and, people working with professional athletes to try and make the right decision of whether they should or they shouldn't be supplementing with vitamin D. One area that we've been working on, and I guess I've not really talked about, or we've not really published any data on yet, is that, and we find super interested in, and an area that we're going to follow up, is that when we look back through our data and we look at some athletes that have higher muscle mass, we tend to see that those guys also have higher serum 25-OHD levels in the winter, despite the fact that all of these guys shouldn't, when we test them, be on any vitamin D or using sunbeds.
Yeah.
They tend to have this higher serum 25-OHD, and that's really brought around this idea that, well, perhaps actually muscle is a storage site for 25-OHD.
Wow, interesting.
And there is actually some sort of more basic evidence that supports that. So there's a paper that's been published which demonstrates actually that the 25-OHD that's bound to its binding protein can be taken up by muscle and actually stored bound to actin for a short length of time. Now, that's not been shown in humans just yet, but it really is interesting to think, okay, if 25-OHD can be taken up by muscle, how long can it be stored there for? How is it released again back into the circulation? And what implication does that have for our supplementation strategies? If we're working with guys who, maybe in a rugby team where we have some players who are 125 plus kilograms and some who are maybe in the 80s, does that have an implication for how we approach supplementation? So, clearly it is quite a complex picture when it comes to variations in athlete vitamin D status. And, I really do think that anyone who's working with large groups of professional athletes, it's something that we really have to take into account. And hopefully our recent review can sort of maybe help assist with the decision-making process.
Yeah, it's a fantastic resource, and definitely, as you mentioned, that decision-making process being so complicated. Because Dan, how does ethnicity impact vitamin D status? Obviously, in working with Canada basketball, a large percentage of our players will often see levels that are persistently low. So how does ethnicity impact this whole story?
This is a fascinating area of the whole vitamin D story. The first thing to mention is that skin pigmentation is certainly a limiting factor for dermal vitamin D synthesis. So we've known for a long time that dark-skinned athletes need longer in the sun to produce the same vitamin D as a lighter skinned person would for a shorter amount of time. And it's actually argued that light skin is an evolutionary adaptation to migration away from the equator.
Yep.
So that's pretty interesting in itself. Ethnicity does also seem to have another effect on the vitamin D endocrine system through population-wide genetic variations. So there's been a number of studies now that have kind of sought to identify whether differences in ethnic cohorts respond differently to vitamin D supplementation, because it seems that Black and Hispanic men, for example, have a higher risk of osteoporosis and fractures, but they actually have a lower 25-OHD than Caucasians. So one area that's kind of been explored to try and account for this is genetic variations in vitamin D transport system and vitamin D metabolism. So, I mean, just to give a little bit of background, vitamin D, or 25-OHD, when it's circulating in the blood, about 85 to 95% of that is bound to the vitamin D binding protein. And only about 10 to 15% maximum circulates as bioavailable or free. And what's been suggested is actually that due to genetic variations in the vitamin D binding protein, we may actually see variations in the free fraction or the bioavailable fraction, meaning that despite the fact that Black individuals have lower 25-OHD, they may actually have higher amounts of the bioavailable fraction.
Fascinating.
So this has kind of brought about this idea, well, should we be measuring more than just, total 25-OHD? Do we need to start to be looking at, at other things as well? So there are certainly ethnic differences between populations of individuals that do lead to differences in the vitamin D endocrine system. And again, it's something we don't know enough about yet. And for sure, it's going to have implications for the way that we supplement with vitamin D going forward in the future.
And Dan, do you think we are measuring the right thing in terms of being able to measure both the 25-OHD and actually starting to measure the 125 as well in concert? Is that something clinicians should be considering to get that assessment of bioavailable D rather than just simply relying on serum D, which is most common practice?
Yeah, I mean, certainly what we're doing going forward is suggesting that, in addition to measuring total 25-OHD, that, clinicians could move towards also measuring the bioavailable fraction for sure. There are assays available out there for this. So one of the limiting factors in the past was that there wasn't really a commercially available way to measure that bioavailable fraction. That is available now. We've seen a number of individuals and groups. Some select few teams, sports teams, are starting to move towards this as well. And it's something that we are spending a lot of our time now thinking about, and a lot of our research efforts are going into measuring both of these metabolites, because we do think that there may be subtle differences that might be able to explain physiological outcomes better than just measuring total 25-OHD on its own.
Yeah, that's fascinating stuff. And if we continue on this road talking professional sport, a lot of professional teams and elite teams have gotten into a practice, in the last few years of megadosing vitamin D. Taking 50,000, 70,000 IU, one day a week as sort of a time-efficient strategy. Sometimes if athletes aren't going to be as comprehensive in taking their supplements daily, it's an easier strategy to do that. So you've written a whole paper on this topic, obviously. Can you walk listeners through some of the potential consequences of taking, one large bolus of vitamin D?
Yeah, for sure. So, what you just described was actually kind of the reason that got us to think about this and to do a study on this, is that in our applied experience, working with clubs and, working alongside practitioners from other clubs, we saw that it was quite common that people were dishing out the whole week's worth of vitamin D in one dose. Quite commonly, as you suggest, we've seen 50 to 100,000 international units given at once, which is a really, really high dose of vitamin D.
For sure.
And if we think that the RDA for vitamin D, even though it might be a bit low, it's 800 international units. So if we're given 100,000 in a day, just to give listeners a bit of
some reference as to super physiological dose there, right?
It's massive. It's massive, and it's not just really in professional sport where we see that. There are medical reports out there published where you see 100,000 international unit injections to try and deal with things like rickets or osteoporosis.
Wow.
And the key thing here, I guess, is that, well, what we wanted to do was look at this from a professional athlete standpoint. So we were working with, at the time, myself, Graham, and a guy called Warren Bradley, who's a sports nutrition practitioner. We were looking at the time at two different dosing strategies in 46 elite rugby players. So one strategy was 35,000 international units per week, and one was 75,000 international units per week for 12 weeks. And what we wanted to do was actually go, okay, let's look at all of the or at least all of the vitamin D metabolites that we can actually measure at the moment. So that included total 25 OHD, 125 OHD, the bioactive metabolite. We also looked at the product of 25 OHD catabolism, which is 25 OHD. And we looked at this across this time course of 12 weeks. Now, what we found was, we think was really interesting. The main finding was that 70,000 international units per week may actually have been more detrimental for its intended purposes than actually going with a lower dose. And the reason for that is because we saw an increase in 24-25 OHD production. So we saw an increase in the catabolism of vitamin D. Now, not only did we see that breakdown in vitamin D, we also saw that if we quickly took athletes off that supplementation, the 24-25 OHD remained elevated, whereas the 125 OHD and the 25 OHD started to come down. So in the face of declining concentrations of the actual active metabolites, we're seeing an increase in the catabolic metabolite, which could actually have negative consequences for vitamin D signaling in all of the tissues that vitamin D exerts its effects. So we showed two things really, which was that high dose supplementation is really not the best way to go about supplementing athletes with vitamin D. And the second thing is that if you rapidly take them off that high dose, it could have even worse consequences. So what the data really imply is that lower doses of vitamin D ingested frequently, so on a daily basis, and a gradual withdrawal from supplementation as we get into sort of the sunnier months when we don't need vitamin D is probably the best way that we need to go about supplementation.
Yeah, I mean, that's a really, really important finding you guys had there. I mean, even last year I was at a strength and conditioning conference, and one of the speakers was actually advocating for using these sort of big doses without considering some of the things that you're mentioning here. So yeah, definitely pretty important stuff, and a really important one for practitioners to make sure they're double checking. I know a lot of athletes will just take that vitamin D bottle and sort of go for it,
That's for sure. I think, regulating that, I mean, from a practical nutrition perspective, having the vitamin D just out on a table is probably not the best thing to do with athletes because, as I guess everyone listening knows, if athletes think something's good, they think more of it is better. So sure. If vitamin D is left around and they're taking big high doses, it's probably not having the intended effects that you want. And there is always a risk of toxicity if it's a chronic intake of really high vitamin D.
Yeah, great point. And Dan, I want to kind of segue this conversation on vitamin D to your recent work around exercise-induced muscle damage now. And, of course, a lot of nutrients and functional foods have been looked at for their potential to ameliorate things like exercise-induced muscle damage, accelerate recovery. But, of course, there's a trade-off, right, between recovery and adaptation, which you guys highlight very well. And very few studies have actually examined that sort of balance between the right amount, that adequate stress to trigger adaptation and the need to avoid adding unnecessary supplementation on the back end. Can you maybe set the stage here for listeners on your paper and highlight some of the markers of exercise-induced muscle damage?
Yeah, I mean, the classic, the hallmark of EIMD is a loss of force generating capacity. So if you're going to measure anything as a marker of exercise-induced muscle damage, it should be a loss of force, a loss of function. Alongside that, we also see big increases in soreness. A disturbed perception of limb position as well can also occur. And these markers tend to last from anywhere between a couple of days up to 14 days after the event. So usually most of the markers peak at around 2 days after a damaging event. And everyone knows when they've done something unfamiliar, 48 hours after you got that real tender muscle, and that's classic exercise-induced muscle damage.
For sure.
The mechanisms that underlie this are typically some disruption of the sort of muscle machinery that allows muscle to contract, and also a bit of damage to the muscle membrane. And because of that, we see increases in intracellular calcium, potentially increases in reactive oxygen species. That all gets cleared out. The cell debris gets cleared out by the immune system, and then the muscle gets repaired and remodeled intrinsically, and also through a contribution of the muscle stem cells too. So that's kind of the whole process in a nutshell, I guess.
Excellent. And, let's talk polyphenols here for a minute. Fruits and vegetables, obviously rich in polyphenols. Many possess the ability to inhibit, COX enzymes to a similar magnitude as things like NSAIDs, your over-the-counter anti-inflammatory. So can you start the conversation here with maybe a little discussion on cherry juice and what phase it might support and how?
Yeah, so cherry juice is obviously polyphenol-rich functional food, as it were, which essentially means that it's got some ability to have a positive physiological effect, maybe preserve health or prevent disease to an extent. The mechanism by which that might have a positive effect is really still being researched, but I think it's probably unlikely that it has any direct antioxidant activities. I don't think it can probably act as a scavenger of free radicals or anything like that. It's probably more likely that whatever's in cherry juice has some ability, first of all, to ameliorate some signs of muscle soreness. There have been some studies that have shown that. But it's probably likely that the polyphenols or the active metabolites within cherry juice can act as signaling molecules that stimulate adaptation. And you're right in saying that, with all of these things, if we overdo it, if we have too much of them in a phase of exercise where we have only a sort of modest stimulus, it may be that they dampen that stimulus a little bit. So what we've kind of, our theoretical framework, I guess, that you could say in one of our recent papers was that, the exercise stimulus is kind of like a bell-shaped curve, or it's a hormetic effect, whereby up to a certain point, we have a gradually increasing exercise stress that results in a positive response or an adaptation. Now, after that point, at the sort of curvature of the bell shape, we start getting onto the descending limb of that positive adaptation, and the exercise stress is a little bit too much. And you could consider that to be sort of excessive muscle damage with certain types of exercise. And what we've postulated is that it's potentially that region whereby the exercise stimulus is a little bit too much, in where we can have where we could utilize these functional foods to our benefit. What we've kind of suggested is that these functional foods like cherry juice or other similar polyphenol rich foods if we include them in the diet, the worst case scenario is that we've included important vital nutrients in the diet. And the best case scenario is that it might exert a positive effect. So I think, with these type of functional foods, we can't really go too wrong here. Advocating that athletes include them in the diet is a good piece of advice anyway.
For sure.
And using them potentially to our advantage in periods where, we've maybe gone quite heavy with the exercise stimulus, the exercise stress, or maybe there's a bit of muscle damage. That could maybe alleviate some of the symptoms associated with exercise-induced muscle damage.
Yeah, absolutely. Particularly as it relates to, as you mentioned, just eating real food, of adding those polyphenol-rich foods in the diet. Sort of a can't-lose situation there. And, Dan, what about omega-3? The evidence on its effects for muscle function, oxidative stress, inflammation. I know some folks think there's a lot of potential benefit. Others view the evidence base as being maybe not showing as much support. What are your thoughts there?
Yeah, I mean, again, just to, I guess, set the tone a little bit, polyunsaturated fats like omega-3, they are important for our health in general. We get them from foods like nuts, mackerel, tuna, and they are the type of fats that we do actually want to be including in the diet. So in any case, it's something that we do naturally want to be having in the diet. In terms of the effects on exercise-induced muscle damage and that area, there are a few studies that have looked at potential supplementation and whether it could alleviate some or, the majority of exercise-induced muscle damage markers. And in general, the consensus is that for EIMD, there may be some benefits of supplementing with omega-3. I guess probably the most extensive study done on this was by Chris McGlory, who is at McMaster University.
Canadian, nice.
Yeah, well, he's English.
Oh, is he? In Canada, there you go.
And I will also mention, a previous John Moores University student as well. So,
fantastic.
Super proud of the guys that have come from all that. But, Chris did a nice study where he showed that a minimum of 5 grams per day of fish oil, which equated to around about 3.5 grams of EPA, and I think it was almost a milligram of DHA, was necessary to actually permit any detectable increases in omega-3 within the muscle. So, collectively, I would say that the studies are suggestive that there could be a positive effect. We're certainly not there yet, if to say that it certainly does have an influence on exercise-induced muscle damage. We definitely need to be having a higher dose than you would probably get just from the diet. And there are guys such as Ollie Whittard in Sterling who are doing a lot of work around the positive health benefits of omega-3 of fish oil. So I'm sure this area is going to continue to grow, and they're the guys that really who are to follow to stay on top of this research.
And what about younger athletes, Dan? I know a lot of our young basketball players, young athletes in general, I mean, we can probably pretty much say is, the diet in terms of things like shellfish or fish is typically going to be pretty low, oftentimes non-existent. So do you feel that's a place where supplementation is likely a good spot to be adding some of these things in that athletes unfortunately aren't going to be getting necessarily as much from a food-first approach?
Yeah, potentially. I mean, the place that we always start with this is if athletes aren't getting much in, we do try and introduce it into the diet first and educate around this, and
for sure,
and use practical ways, I guess, to improve their uptake just from the diet. In terms of supplementation, yeah, for sure. We fish oil supplementation is one that if they're not getting enough through the diet, we can follow that. I don't know if you've seen Graham Close's supplementation decision tree, whether you should supplement or not. But, if we do get through all of those questions saying, can we get enough in the diet? Okay, well, the athlete isn't. Can we get a batch tested version? Yes, okay. If we can work our way through that, then yes, it certainly could be something that we could use with younger athletes. In terms of the dosing, though, I'm not sure there's any research to say whether doses need to be altered based on age for the younger guys. So, I would kind of say stay conservative with it, just to be certainly just to be safe. But for me, the way I always try and approach these things is just improvement of education, and actually trying to increase dietary uptake first.
Yeah, terrific. Absolutely. It's a great first place to start, is always setting that foundation with the diet, for sure. And that sort of dovetails here into my next one around vitamin C and vitamin E, two essential nutrients, obviously commonly known for a lot of athletes, especially even younger athletes. How do they stack up in terms of exercise-induced muscle damage?
Yeah, so again, an area that's been pretty extensively researched over time. What I will say is that it's an area that my colleague and mentor Graham Close has done a lot of work on. Also, James Cobley. Also, they both of those guys have done heaps of work on this, and wrote really good, insightful opinion pieces on this. So that's certainly, if listeners are interested, go to those guys and find their research, because it's really interesting stuff around vitamin C and E. What I will say is that one of the things that came out around vitamin C and E was actually that if we're supplementing with high doses of vitamin C and E, it may actually have a negative effect on muscle function and on some aspects of muscle remodeling as well. To be honest with you, I'm not sure really what we think about that anymore. That old school opinion that they're acting as oxidant scavengers, as antioxidants, as it were.
Yeah.
And the reason for that is really because we don't really believe that these vitamin C and E can accumulate in a sufficient amount at the site of free radical production. So that's really important, because a lot of the reactive oxygen species that are thought to cause some aspects of macromolecular damage, they're only existing for a very short time and damaging things that are in a very close proximity. So in order for vitamin C or E to actually have any effect, they'd need to accumulate right near the site where the free radicals were being produced. And we don't really think that that's possible, theoretically anyway. What we think is probably a more likely scenario is that if they are going to have any positive effect, it's probably going to be through acting as signaling molecules. So, whether they have a positive or a negative effect, I guess that remains open. But, as you said, these are vital nutrients that we need to be getting through the diet. So, no one should be avoiding these things. What I would say is that taking sort of mega doses of vitamin C and E is probably not going to be useful either. So
yeah, it's definitely a common one, along with the D, that I would see in whether it's personal trainers, certain athletes, or even recreational athletes. Of the vitamin C, the vitamin E, the vitamin D tend to be the ones that people will go to increasing amounts. So really great insights on that front.
Absolutely, and I think again, the key message here is that we've got to start with the diet. We really have to get a really varied, balanced diet that's rich in vitamin C, rich in vitamin E, rich in all of the nutrients that are common within the diet. Obviously, vitamin D isn't, but we really have to start there before we start thinking about anything else. And 9 times out of 10, if we nail that, then we're pretty much gonna be spot on with our vitamins anyway. So, I always say start there and then work upwards. And then if we see that, okay, there's a deficiency, maybe we need a little bit more, then we can start to think about supplementation and sports nutrition and all the rest of it. But for now, I think that, for vitamin C and E, we should just be trying to get most of that through the diet.
100%. Very well said, Dan. And definitely want to respect your time here. So before we wrap things up, last couple questions here for you.
Yep.
What do you think the evolution of research with vitamin D and athletic performance is looking like in the next 5 or 10 years?
So at least from our lab, we're going down the avenue of trying to identify whether bioavailable vitamin D is a better marker of vitamin D status. We're also going to try and answer the question of, well, if that is the case, can we potentially increase just the bioavailable fraction as opposed to the total fraction? So, from a supplementation point of view, that's where we're going. From a mechanistic point of view, we're kind of exploring a number of different avenues. We're trying to really identify how vitamin D might exert positive effects within muscle. We're also quite interested in vitamin D and its potential to interact with mitochondria as well. So, for us, that's the next 5 to 10 years sewn up right there, because that's going to take a lot of our time. And that's what kind of what we're working on. I know that some of the labs are looking at vitamin D and its potential for dysregulation in obesity and certain aspects like that as well. So for me, I think it's all going to be around how we kind of personalize vitamin D supplementation, taking into account these genetic factors we talked about earlier, taking into account population-wide ethnic differences, and really having a bit more of a personalized approach to it.
Fantastic, Dan. And I've saved the last question here, the toughest question. I know you're a big Liverpool fan.
Yep.
Any predictions on the rest of the season here? How are things going to go for the club?
Yeah, that is the most difficult question.
Don't want to jinx them, right?
After today's victory against Man United, I'm feeling really good. So I'd probably go and say, we could go on and do some great things, but I wouldn't want to jinx it. But certainly, it's a great time to be a Liverpool fan. It's exciting football. So I don't know. Let's hope that if we speak again in a year's time, that I can say that we won the Premier League.
Fantastic. Well, listen, Dan, I really appreciate you carving out the time today. Where can people stay connected with you and keep up with your phenomenal research?
So Twitter is where I'm pretty active on Twitter. So my Twitter handle is Dan_Owie. So that's OWIE. I'm on LinkedIn as well. I'm also on ResearchGate. So, if you just type my name in there, you should be able to find me, and anything related to vitamin D, you'll know it's me. So, if you want to send me any questions, you can contact me on any of those platforms. Always happy to talk about the work we're doing. And also happy, to chat about applied work as well, if anyone wants to get in touch. So, yeah.
Awesome, Dan. Yeah, definitely appreciate you taking the time. Really insightful here today, and definitely something that's helped us a lot at Canada Basketball. So appreciate all your fantastic research. So we'll definitely include those links and some of the papers that we discussed here in the show notes at drbubbs.com/podcast. Thanks again for everyone else tuning in. If you